In contrast to serious HEVs, parallel HEV is another common concept that you see in hybrid electrical vehicles. Now, the configuration is quite different in the hybrid electrical vehicles. Now, if you look at the diagram on the right hand side, the components are very similar. We have the fuel, you have the engine output, you also have the motor, and you have the motor controller. But the energy flow is quite different in that the output of the engine is actually connected to the wheels or through the mechanical transmission. The output of the electrical motor here is also connected to drive the wheel. Okay, and the output of the engine, the output of the electrical motor, they're both mechanical energy. They are connected together through some kind of mechanical arrangement called a coupler. So they actually together they add all the driving forces or traction effort together, and then that in turn the coupler, the output from the coupler drives the mechanical transmission. So because engine and motor are working in parallel, so that's why this particular configuration is known as the parallel hybrid electric vehicles. And in addition to that, of course, we want some flexibility in terms of management of electrical power in the system. So therefore, the electrical motor, on the other side of electrical motor, we also have a battery through some kind of power electronics so that the energy can flow from the engine for the fuel tank to the engine to the wheels. The energy can flow from the motor or the battery, the motor, and drives the wheel as well. So in this case, there are different working modes. Okay, so we need a battery to drive the motor, and we need the motor to produce the mechanical power, but we also need the engine to produce the power. But the engine and the motor can output the power or the mechanical power to drive the wheels together. And also we can actually use the braking power to charge the battery. Okay, of course, the battery can be charged externally from other sources as well. Now, parallel hybrid electric vehicles also have several different working modes. The first mode is the motor alone. So in this case, the engine is switched off. So engine is not doing anything. It's not burning with fuel. It's not outputting any mechanical power at all. It is the motor that's used to drive the wheels alone. And of course, the motor is powered by the batteries through the power electronic circuits. So that's first mode. Now, typically, that is a mode is not going to last for very long because the battery typically in a parallel hybrid electric vehicle is not really that large. It doesn't really store that much energy. But nevertheless, when the energy is sufficient and the parallel HEVs can work in that mode. And of course, when when the driver asks for a lot of power to accelerate under harsh working conditions, in this case, the engine is turned on. The motor is also supplies power to the wheels. So both will give you the maximum driving force or driving torque to the wheels. That is probably the most common mode in a parallel hybrid vehicle, when the engine and electrical motor work at the same time to drive the wheels. The third one is the engine alone, in which case, either because the battery doesn't have much power left, or the engine or vehicle is traveling at a speed that best suits the engine. Okay, make the engine efficient high in this condition. In this case, the computer or the control system on board might decide that we don't need the electrical motor at the moment, so therefore we can actually switch that part off and keep the engine going, and that drives the electrical motor, drives the vehicle forward. Now, it's typically when the demand is not very high. Condition number 1 and condition number 3, or the mode number 1 and mode number 3, are both when the demand for driving or for traction output is not that very high. Okay, whereas the combined work mode it needs to be switched on when the driver is trying to do something, deliver the high performance output. But the difference between the motor alone and engine alone is, one, whether there's enough battery power left. 2 is whether the vehicle is traveling at the speed range that suits engine the best. And of course, when the car or the vehicle is stationary, a vehicle is not driven or the cruising, whatever, so you don't need output to the wheels, then you can actually use the engine to drive the electrical motor. The electrical motor would be controlled to behave like a generator that produces electrical energy to charge a battery. So that's a possibility. Finally, you can have, when you are braking, and you can use this energy, you can convert the kinetic energy of the vehicle back into the electrical vehicle energy and stored in the battery. So again, in this case, the traction motor, or the motor drives the wheels, is no longer providing a driving force, but it's actually reversed. It will act as a generator to produce the electrical power to charge the battery. So 5 different working modes for parallel HEVs. Okay, and of course, their parallel HEVs will have their advantage and disadvantages. Now, because you have an engine that's connected to the wheels through some kind of mechanical transmission, the gears or clutches, that kind of stuff, therefore you don't really have to have very large generators or traction motors. So traction motors and generators are used as kind of add-on energy to improve the efficiency. That's another advantage. But disadvantages of parallel hybrid electrical vehicles, including things like complex mechanical connections between the engine, the motor, the driven wheels, but also the complex control and power management system to decide when to do what, which mode you want to be in, when do you want the engine to work, and when do you want motor to switch on, and when is the best, under what condition will give you the most efficient way of functioning. Okay, it can be quite complex, the decisions. It's actually less straightforward. The control or management system part of parallel hybrid electric vehicles can be quite complex and less straightforward than the series hybrid electric vehicles. And sometimes people say, right, well, because there are advantages and disadvantages of series and parallel hybrid vehicles, why don't we put them together and combine, take the benefits of both? So therefore, this is another possibility where the engine you add, everything else is very similar to series HEVs, but you also add a mechanical link, or connection between the engine and the wheels through the mechanical coupling power system. So it is possible, when it is needed, to drive the wheels through both engine and electric motors. But again, because you are adding extra mechanical connections in a vehicle, physically and cost-wise, it makes things more complicated. Okay, so you are really trying to sacrifice mechanical complexity or increase the mechanical complexity in order to gain some advantages. Now, in the early days of the development of hybrid vehicles, and all sorts of different configurations came up, but some of them got very popular, some of them perhaps less popular. But nowadays, people tend to move more towards the electrical side. So the latest you would see, or the most sort of electrical vehicles are at the moment on the market are things like plug-in HEVs. Now, plug-in plug-in HEV or plug-in hybrid electric vehicles will have much larger batteries. But we don't need large engines or generators anymore, unlike what you have on a series hybrid vehicle. Okay, or series, because all the main energy will come from the industrial internal combustion engine. Therefore, the engine size and the used to generate electrical power will need to be large. But for plug-in HEVs, the battery will carry a lot of energy. Therefore, you need a large battery pack. The charges, because it's plug-in, that means you can charge that externally. You charge it from power socket on the wall or some dedicated vehicle charging stations. But on one charge, the battery is large enough to cover a reasonable range. Therefore, you don't need large engines. So that really is the main difference between the conventional series HEV and the plug-in HEV. Is the size of the battery pack and the size of the engine and the generator. And of course, that needs not only the large battery pack, because the engine and generator are not big enough, so they are on their own can't really be used to do any serious driving. Therefore, the range of the vehicle is important, means how much energy you have in a vehicle stored on board, and also how fast you can charge these batteries. Because if you say the best plug-in electric vehicles nowadays probably will cover 100 kilometers or cover 200 kilometers at the maximum. Therefore, once this distance is up, you need to charge it. Sometimes if you are on a long journey, and the speed of charging is important. So that's the disadvantage. So potentially this kind of vehicles, you will find it difficult to drive for very long. Now, because the small engine and generator involved with the plug-in HEVs, now there's argument to go and get rid of the engine and generator altogether, because they are very small, they don't really provide much energy, and you might as well use the space and the cost to put more battery on. That leads us to the full electrical vehicles. Now, it is very similar in configuration to the plug-in or series HEVs, but there is no combustion engine, there is no generator. The only source will come from the batteries stored on board, or fuel cells that produce electrical energy from oxygen and hydrogen, or some kind of other sources. Now, because there's no combustion engine, there's no generator, therefore the only energy source you have is likely to be either a battery or some kind of other electrical energy source. So you need to make sure that one charge will be enough to cover the entire range. So the long range, there are large value for long far distance is needed. If vehicle manufacturer expect people to buy the best electrical vehicles now on the market, is probably in terms of range, you probably look at a Tesla that covers about 300, maybe a bit more than 300 kilometers per charge. That would be enough for most of people, except for some exceptional circumstances where people really need to drive very, very long distances, and when the speed of charging or how much time it takes to charge a battery becomes an issue. Okay, so these are the main different types of hybrid or pure electrical vehicles. You have series hybrid vehicle, you have parallel hybrid vehicle, you have series and parallel, you have plug-in, which is very similar to series, but major difference is in the size of electrical motor. Sorry, the size of the battery pack and the size of the engine and generator. And of course, if you get rid of the engine and generator altogether, you end up with pure electrical vehicle. The energy for electrical vehicle or plug-in electrical vehicle are mainly from external charges. Okay, so people buy that kind of vehicle would probably need to install some kind of charging station in their garage or near their house, or rely on charging stations in their workplace to keep the vehicles charged up. Of course, there are many challenges, because electrical vehicles or hybrid electric vehicles involve a lot of new and key technologies. And not only the cost, the range, and how the size also matters, because the size of a car is limited. The weight, you don't want to carry unnecessary weight and drive that from point A to point B because they always energy. And how durable they are, how long they are going to last. Okay, so there are a lot of additional issues for hybrid electric vehicles or pure electric vehicles that people need to consider. First thing, of course, comes to people's mind is power electronics and electrical machines. The motors and generators are electrical machines, and the control of electrical machines require power electronic circuits. Now, of course, these things are not new. People have been sort of studying these things for a long time, and they are used for other applications as well. Power plants, they use not very large generators, and industrial drives, motors, even domestically sometimes you also see, for example, your lawnmowers, they can use electrical machines. Your drills. So the subjects of power electronics and electrical machines are not really new, but the application of them in a vehicle environment is quite different to other applications, because other applications tend to be in a fairly static conditions. They're not moved about. But vehicles, if you think about it, they're not only, because they are vehicles, they are transport tools. So they move from point to A to point B all the time. But also, you have roads. Roads are not ideal. You have bumps. So therefore, there's a lot of vibrations occur on a vehicle. You can feel that in the car as well. But also, cars are parked outside. They work. They sell to different regions, different countries, and you have seasonal changes of temperature. And when you drive, the motor gets hot. The temperature goes up and down. When it snows outside, the temperature can get very low. But power electronics and electrical motors, they have to work in all these different conditions. The temperature changes, the vibration, they have to be reliable enough, things like that. So there's a lot of design issues for electrical machines and power electronics. Then there's also an issue called electromagnetic interferences. When the motors or generators are controlled, they rely on power electronics. Power electronics are switched at very high frequencies to generate the desired output. Now, these switching operations produce electromagnetic noises that can interfere with your control systems or your radio system. Okay? So therefore, when you design the vehicle, you need to make sure the interference caused by power electronics do not affect the safe operations of your control systems, or it doesn't affect anything nearby around the vehicle. Okay. So that's another issue. Then there's also the issue about thermal management. When the vehicles are running, the motor are running as well. Now, any system that's running produces losses. Losses tend to convert it into heat. Heat increase the power. But power electronics, electric machines and batteries, they don't like very high temperature. So they really need to be controlled kept under certain temperature range. So you need to make sure the heats are properly, well, first of all, you want to minimize the losses, therefore reduce the thermal effect. But also you need to make sure that any heat produced in the system is dissipated properly. The power management and the vehicle control is another thing that involves very complex control algorithms. Because now the system is a lot more complex, and the demand for high efficiency is increasing as well in order to reduce the losses. So there's and then the cars are used in unpredictable conditions where you drive up down the hill, external wind, roughness of the road, the driving speed, all that sort of stuff require careful, coordinated control. Okay, and you want to make sure different parts of your drivetrain work in an integrated manner. Okay, so optimal conditions don't just happen at subsystems level. You need to take an overall view. How to make sure system work in the best condition, give you the highest efficiency. And also, energy storage is another issue because nowadays it provides the most energy required to drive the vehicle. Whether we're going to use batteries or another device called ultra capacitors, or sometimes called supercapacitors. They also provide the means to store energy, but the supercapacitors or ultracapacitors charges faster and dissipate output power faster than the battery as well. But they tend to be able to hold less energy in. They're not as good as batteries to hold much energy. And it is possible sometimes people use mechanical energy storage devices like flywheels as well. Okay, how you get all, if you want to use all or several different energy storage systems in a single vehicle, how are you going to coordinate and make sure they work in the best manner? Okay, regenerate braking, again, that's another issue. The difficulty with regenerate braking is that you need to make sure you charge the battery or charge the supercapacitors. But capacitors, sometimes, often they can only be charged at a certain rate. So any excess, you need to consider that in combination with the need to brake, how fast you can brake and how fast you need to brake. Sometimes you have to dump the energy or dump part of energy into a resistor, or sometimes you may have to use mechanical brake as well. Because at the end of the day, safety is more important than how much energy you recover. Okay, so there's two things here. How much energy you can recover and how safe your braking performance is. Okay, so very many complex issues and environmental issues that goes without saying. Pollution is possible causes. Okay, about the batteries and things like that. But you can read all the rest of it because there are a wide range of issues involved in the environment, things like leaks of chemicals and things like that. Okay, so that is really the first topic of my part 1 covered. And I'll leave you with some fairly simple practical questions. Most of answers are provided in my slides, but make sure you go over with these. Make sure you actually know what the answers are. Okay, either if you're not sure, if you don't find them in my slides, go over my video again because I would definitely have said it somewhere. Okay, thank you.